everyone, I'm Vedanti, Khode, and here we're going to discuss about working of ceiling fans through some simulations.
But where does it all comes from? The inventor, Philip Dale. He is a German-American mechanical engineer who worked for the Singer Sewing Machine Company and invented an electric ceiling fan using sewing machine motor. Now these are the parts of ceiling fan: base plate, down rod, housing cover, motor, blade, and pull switch. Moreover, we're going to concentrate upon the motor in the upcoming minutes. Now, let's get started with GeoZebra. This is the result of what we have today, where start and stop buttons represent switch, 1, 2 and 3 speed levels represents regulator, the red wire is phase, black one is neutral, and green one is earth or ground. Generally, we pass 220 or 120 volt of AC supply through phase. Now let's play with animations. Start. Speed 1, speed 2, and speed 3. Stop. Cool. Now, I'll take you to some internal stuffs, but in 2D wave. This is the two-dimensional structure of motor. As can be seen, the middle light gray structure is stator. The outer pink ring is rotor. The dark gray ring is secondary winding. The purple ring is primary winding. And these are the wires through which we're going to pass AC current. The primary winding is also called main winding, and secondary winding is also called auxiliary winding. And the black moving dots are showing the moment happening in the rotor. Now let's get to the 3D wave. Now this is the simulation of fan. Here we go. Here the maroon colored cylinder represents capacitor. The dark gray rod is down rod, whereas the blue plates are the blades, and the black ring is rotor, as well as the gray cylinder is stator. The internal windings are auxiliary windings, and the outer ones are the main ones, represented symbolically. Now let's get back to the motor. Ceiling fan has a motor that is single-phase induction motor that converts electrical energy to mechanical energy. First of all, I'll show you how the stator, its windings and rotor look in reality. Okay, so this is how it is. On the left hand side is the stator with its copper windings. Both of the windings can be seen. Also on the right hand side is the rotor, which consists of the conductors which are inside it. Getting to know connections better. Now I'll show you how the capacitor and both of these windings are connected together. Well, yes. Now I hope it's a clear vision, because this is how they're connected. While auxiliary given neutral and main given phase, both connected to a capacitor, as well as stator consists of both of the windings. And the outer brown ring is rotor. Inside it is symbolically represented shaft. Getting back to the working and simulation. Ceiling fan works on the principle of electromagnetic induction. Well, as per the connections, when AC current passes through the stator windings, it creates a rotating magnetic field. Since rotor and magnetic field are in relative motion, therefore, according to Faraday's law, EMF will induce, leading to current flow. That is, this rotating magnetic field then passes through the rotor windings to create current in the rotor. Since we know that like pole repels, similarly two magnetic fields repels and causes the rotor to rotate. Capacitor is used to start the rotation of the motor. In simple words, we can also say that capacitor just provides a torque, starting torque. Just imagine. Simultaneously taking note of 2 points, that stator is the stationary part or the part that doesn't move, and the rotor is the part that rotates. So this is how electrical energy is converted into mechanical energy as a result of spinning of blades. And then this is how the moment is, as shown. With all of these, hoping that you liked my simulations, I conclude with a sincere thank you